You are once again welcome to today's GRE class. The question we have for today is from the topic rate, speed to be specific. The difficulty level of this question is hard, so let us take a look at it together. A bus from city M, so let us say we have a particular city M. So this is city M at this point. Is traveling to city N. So we have another city N here. So it's traveling to this city at a constant speed. So let's call this bus A, and let's say the speed of this bus is x at a constant speed, while another bus is making the same journey in the opposite direction at the same constant speed. So we have another bus. Let's say this bus is bus B coming from the opposite direction at the same speed, at the same constant speed. They meet in point P after driving for 2 hours. Now, if M and N are two cities, you have one bus traveling from M to N, you have another bus traveling from N to M. Now, these two buses are traveling at the same constant speed. So, if they will meet at a point, it will be at the midpoint between M and N. And the reason is because the two buses are traveling at the same speed. So from speed equals distance over time. So our distance will be equals to speed times time. So since we said the speed of bus A is x, the distance covered by A from city M to P, the meeting point of the two buses, that distance will be 2x. Now the distance covered by bus B from N to P, where the two buses met, would also be 2x. So now the distance between the two cities will be 2x plus 2x. So that will give us 4x. Now all we need to do is find the value of x, and we have our answer. So let's continue. They meet in point P after driving for 2 hours. The following do the return trip at the same constant speed. So now we have A moving towards M now, and then we have B moving towards N. We have A now moving towards M, and we have B moving towards N during the return trip. If the buses do the return trip at the same constant speed. Now their speed did not change, so we are still using the same speed as used in the first trip. One bus is delayed 24 minutes and the other leaves 36 minutes earlier. So what does this mean? One bus delayed. So let's say it is bus A that was delayed. So A is at this point. This was delayed, and then this one leaves 30 minutes earlier. That means bus B has a 1 hour head start. So together, how did it come about that 1 hour? So it will be 24 plus 36. So one leaves earlier. The other one was delayed 24 minutes. So that means the other bus has been traveling for 60 minutes, which is 1 hour. So that means B. So we can take any of the buses to have been traveling for 1 hour before the other one started traveling. So I've decided to take bus A now. Okay, or bus B. So bus B is now moving from M to N. So let us say bus B was the one that traveled 1 hour ahead of bus A. So in that 1 hour, in that 1 hour, bus B would have traveled um, distance will be equals to speed times time. So the speed is x, time is 1. You would have traveled x, a distance of x. So let's say that is x miles. You would have traveled a distance of x miles. So that means the distance from this point to n will now be 3x. The distance from this point to n will now be 3x. So how did I get 3x? 4x minus x. Remember, from m to n is 4x. So if we subtract x, we are going to be left with 3x. So let's continue. If they meet 24 miles from P, so if this one has been traveling for 1 hour, so this one will travel a distance longer than the other one. So if this is P, so let's assume the two of them meet. They meet at this point, which is 24 miles from P, which is 24 miles from P. So that means this we have to travel from this point to this other point here, which is 24 miles from P. So this bus A now is moving, will move towards the direction to meet B at this point. So that means the two of them need to cover a distance of 3x miles. So how do we find the time in which the two of them will meet? So we use the concept of relative speed. So when two uh, objects are traveling at opposite direction, you add their speed. So that means the time required for that to happen will be the distance they need to cover is 3x. The sum of their speed is 2x. So that means that will take place at 1.5 hours. So that means at 1.5 hours, after B has traveled for 1 hour, A and B will meet at a point 24 miles from P. So now all we need to do is to calculate the distance covered by A during this journey. So we know that this is what is left now. This is distance covered by A from this point to this point. So the distance covered by A will be from this point to this point. Now, from this point to this point will be a distance of 3x minus 24. Now, since from here to here, from this point to this point is 3x. From this particular point to this particular point is okay, sorry. We know that from here, from this midpoint to this midpoint is 2x, fine. So that means from here to here will be 2x minus 24, sorry. So this will be 2x. So 2x minus 24. So that same 2x minus 24 will be, let's wipe this side out. That same 2x minus 4 will be equals to speed times time for that distance. We know that the speed is x. The time that A will cover that distance will be 3/2. So that means we have 3/2 times x. And then we can then go ahead and find the value of x. So multiplying everything by 2 here gives us 2 times 2x will give us 4x minus 48 equals 3x. So making x the subject of formula will give us x equals 48. Now remember, it is the value of x we need to calculate the distance between city M and N. So that distance will be equals to 4 times 48. 4 times 48 will be equals to 4 times 8 is 32, carry 3, 4 times 4, 16 plus 3, 192. So that makes our answer E. So that is all for today. If you like what you have seen, you can go ahead and like my channel, subscribe to it as well. And then if you like dropping a comment, you can as well go ahead. So thanks for coming and hope to see you again next time. That is all for today. Bye bye.